Okay, so those are two types of permutations you'll run into. A permutation with all of the objects, where, it's just boils down to a single factorial, or a permutation where we're only picking out some of the objects out of the total, like we did here. And we can use this formula for either of those cases. Now there is one more case, because why not, right? Permutations with repeated objects. And the good news is you're going to see these problems are all going to be very similar. In fact, they're all going to be problems like these two that we're about to do. And actually, I'm just going to show you can read through this definition, but it's super mathy, as you can see. Let's just do an example. So, example 1. In how many ways can the word pass be arranged? So this is kind of similar to the ABC example, right? How many different ways can we reorder these letters? But it's a little bit different because in the ABC example, every letter was different. Here, that's not the case. Not every letter is not different. So you know what? I'm actually going to erase this real quick. And I'm going to write P-A, and I'm going to put the S's in two different colors for a reason. Okay, so before we actually figure out the number of ways this word can be rearranged, let's just see what's going on. Let's find some of the permutations. I'm not going to find all of them because there's going to be a lot, like 24, and I don't want to write this out 24 times. But, so for example, another way we could rewrite or rearrange these letters, we could have A, P, blue S, green S. Now I'm having these in two different colors because they're the same letter, but there's two S's, right? And they're not the same exact S. So that's why I did one in blue, one in green. So another way I could rearrange this is A, P. Technically, I could switch these two S's, right? So I have a green S first, and then a blue S, right? I just switched the two S's. Now we end up with the same exact ordering, A, P, S, S, A, P, S, S. But remember, those two S's are different. And we can keep going in that way, right? And if you keep going, you'll find 24 different ways to write this out. However, when we actually count this, we don't want to double count the APSS. We don't want to count this as two different words or two different orderings because look, it's not. It's APSS, APSS. It's the same ordering. So actually, when we count up the total number of ordering pass, we do not want to double count in these situations where we're just, moving the S's. So that's where this formula comes in. So before we use this formula, we're going to look at how many letters exist. So for example, P. How many times does P show up in pass? There's only one. A. How many A's? There's only one. S. How many S's? Whoop, there's two. Okay. So we looked at every letter and we figured out how many times that letter shows up. Now we're going to use this formula. So the formula is your top number is always going to be however many letters you have. Excuse me, I'm getting a frog in my throat. The top number is going to be however many letters you have in the total word. We have 4 letters, right? So I'm going to put 4 factorial on top. But then what we're going to do is we're going to divide by the repeats, essentially. So the formal way is basically for every letter, we're going to include each of these in the denominator, but with a factorial. So like we'll have 1 factorial times 1 factorial times 2 factorial. Now really, 1 factorial is just 1. So a shorter way to kind of look at this is the total number of letters, factorial on top, divided by any of the repeating letters on the bottom with factorials. And we can simplify this. So I'm going to use that trick where we're going to kind of peel numbers off of 4 factorial. I'm going to peel off the 4, then I'm going to peel off the 3, and then look, 2 factorial. That matches the bottom, so I'm going to leave it at 2 factorial. Those 2 factorials are going to cancel, and then we're left with 4 times 3, which is 12. So there are 12 distinct ways to order the word pass. Distinct as in every ordering is different. If we look at these two, APSS, they're the same. These are not distinct, right? They're exactly the same. So we were concerned with the number of different ways we can order that word. And in this case, it's only 12. So this is taking out all those extras, the extra orderings, right? And there's more than, I only did 3 examples here, and there's a lot more. So just another, we could have A, blue S, P, and then green S, right? And once again, we could technically switch those S's. Ooh, switch, my cursor changed. I hate when that happens. So if we switch the S's, we get A, green S, P, blue S, right? But once again, look, it's technically the same, even though we switched the S's, it's the same ordering. So we don't want to count these twice, just like we didn't want to count this twice. So in the end, there's 12 different ways, distinct ways we can order the word pass. Now, let's look at a bigger example, and we're definitely not going to write all this out like, the different orderings for bookkeeper. That's a pretty long word. So how do we do this? What I would like to do first is we're going to go through and look at all the letters and write out how many letters there are. So for example, for B, how many times did B show up? There's only 1. We got an O, there's 2 O's. K, there's 2 K's. E, we got 3 E's. P, we got 1. And we only got 1 R. Okay. So now we're going to plug this into our repeated objects formula. So on top, again, it's the total number of letters. And in this example, if you count it out, there are 10 letters. So on top, we're going to have 10 factorial. But then we want to take out all those repeated orderings, in case we just switch these 2 E's, or we just switch these 2 K's. So you could, again, list out the 1 factorial, 2 factorial, 2 factorial, 3 factorial, 1 factorial, 1 factorial. You can list all of that out. But remember, 1 factorial is just 1. So just to keep life a little bit simple and not having to write everything out, I'm going to focus on all the ones that aren't a 1. And we're going to be dividing by these numbers factorial. So 2 factorial, 2 factorial, 3 factorial. Okay, let's simplify. So we had a problem similar to this with the factorials. We got 3 different ones on the bottom. I'm going to focus on this biggest one, so I'm going to peel off numbers from 10 factorial until we end up with a 3 factorial. So we're going to be peeling off a lot, right? We got 10 times 9 times 8, 7, 6, 5, 4, and then 3 factorial. All of that divided by 2 factorial, 2 factorial, 3 factorial. And then those 3 factorials cancel. And at this point, I'm gonna write out that denominator. So 10 times 9 times 8 times 7 times 6 times 5 times 4. The 3 factorials canceled all over. 2 factorial, that's just 2 times 1. And then we're multiplying that by another 2 factorial, which is another 2 times 1. And at this point, you can, just multiply the top, and then multiply the bottom, and then divide your answers. By all means, you can do that. I'm a mathematician, so I like to cancel things out if I can. So, for example, what's 2 times 2? 2 times 2 is 4, right? So I'm going to cancel these 2's out with this 4 on top, right? So that's one option because, well, on the bottom we're just left with 1's, and anything divided by 1, you're just left with what's on top. So we just have 10 times 9 times 8 times 7 times 6 times 5. And if you multiply that out, you get 151,200. Now, once again, you don't have to do that. You can multiply this top. I don't have that written down, so I don't know what that value is. And then you can multiply the bottom, and then divide those numbers, and you will end up with the same value, 151,200. It's just really a matter of how comfortable you are with canceling and some of this algebra. So that's all up to you. Okay, so that was permutations. And once again, with permutations, order matters. And in the next video, we're going to introduce combinations. And with those problems, order does not matter. So I will see you then.